All right, we're on day 7. We'll be doing our last bit of topical review, working with velocity graphs today. So from yesterday's stuff, most people finished it in class, but for question 6, we had 20 for the initial amount times 2 to the x over 34 because it was doubling every 34 minutes. 2 hours is 120 minutes. Sub in the 120, we get 231 bacteria. For our number 7, the other one we had to do, get all your slopes. Make sure you have labeled V and T. Draw those slopes in at their proper intervals on the velocity graph. At 3 seconds on the position graph, we are at 2 meters. At 4.5 on the velocity graph, we are at 3 meters per second. So that was C. Our highest velocity is going from 4 to 5 seconds. And then your description, 1 meters per second for 1 second. You could say there's 0 meters per second for a second or stop for a second. And then 1 meters per second for a second, stop for a second, and 3 meters per second for a second. All right, we're going to go over to page 24. We're starting with a velocity graph and we want to go to a position graph. So velocity to position, we do area. Think Vice President of America. When we do the area, that's where we want to do our T chart. So I'm going to make a T chart with our time and our position. So our time goes up to 6 and we want to start with 0. And at 0, there is no area under the graph. So there's our area at 0. There's no area there. At 1, we have a 1 by 1 square, so that would be an area of 1. So at 0, we'll have 0, then we'll have 1. From 1 to 2 seconds, our new area is that square, so we have 1 in new area, so we're now at a position of 2. From 2 to 3 seconds, we have a new area of 2, so now we're at 4. And if we keep going, we have another 2 new, so we're at 6. 1 new, we're at 7. And then 1 new, we're at 8. We'll draw in over on our position graph, labeling time and position. And we only need to get up to 8, so we can probably just scale our y-axis by 1s. And we got to get out to 6 for the time. Now, if they'd given us specific units, like if the velocity was, say, meters per second, then we would do meters for the position, seconds for the time, but we just had in general labeled here. So once we have those axes drawn, we'll just plot our points, 0, 0, 1, 1, 2, 2, 3, 4, 4, 6, 5, 7, and 6, 8. And we'll connect them. And notice when the slope changes, that's when our velocity is changing. So now for our follow-up questions, we're going to give a written description, and it's easiest to give the written description from the velocity graph, so we'll tell how fast and for how long. So that first section there, we typically use meters and meters per second as our units, so we'll say 1 meter per second for 2 seconds. And then we'll go 2 meters per second for 2 seconds. And then we're back to 1 meter per second for 2 seconds. For our next follow-up question, what's the speed of the object after 5 seconds? So for speed, we'll look at the velocity graph. Find 5 seconds on our time axis and see what y value we're at. We're at a y value of 1, so we're going 1 meter per second. What's the position of the object after 5 seconds? So two places we can look. We can either look on our position graph or just look in your t-chart because those are where we got our points for the position graph. And at 5 seconds, we are at 7 meters. And the last follow-up question, at what time does the object first reach its maximum velocity? So notice this is different than yesterday. Maximum velocity, we gave an interval. So now we want to know, when does it first hit that highest velocity? Well, our highest velocity is when it was going 2 meters per second. The instant when it first reaches it is right there. So that's at a time of 2 seconds. All right, going over to our next one. We again want to graph the corresponding position graph. We are given a velocity graph. We want to go to position, so we should be thinking area. So we go up to 4 seconds here. So we'll do our t-chart with time and position going 0 to 4. At 0, there was no area. Now the difference here is we have triangles in our space underneath. We have a triangle with a base of 1, base of 2, base of 3, and base of 4. Our first triangle, this triangle right here, has a height of 1. So we would do 1 times 1 divided by 2 for our area of a triangle, and we get 0.5 back. Our second triangle is right here. It has a height of 2. Notice that second triangle already contains the area of the first triangle. So whatever we get for the area of this second triangle is what we'll put in our t-chart, because it's the total area that has occurred so far. 2 times 2 is 4, divided by 2 is 2. For our third triangle, we have a height of 3. 3 times 3 is 9, divided by 2 is 4.5. And for our last triangle, we have a height of 4. 4 times 4 is 16, divided by 2 is 8. So we'll draw in our axes, and we'll label our P on the y-axis for position and T for time on the x-axis. We only have to get up on the y-axis to 8, so again, it is fine to scale by 1s. And we'll plot those points, 0, 0, 1.5, 2, 2, 3, 4.5, and 4, 8. Notice our position graph is curved, so the slope is constantly changing. And that's consistent with our velocities over on our left. Our velocities were constantly changing. Part B is one of the trickier parts for this one, because we like to describe it off the velocity graph, but our velocity is changing. So we can say that we increase from 0 meters per second to 4 meters per second, and then we'll tell for how long that occurred. So over 4 seconds. And this makes it clear that the velocity was changing on over what period of time it was changing. For our next follow-up, what is the speed of the object at 3 seconds? So speed, we want to look at the velocity graph. So we'll go over to 3 seconds on the time axis. We'll see what our y value is, which happens to be 3. So we'll have 3 meters per second. What's the position of the object after 2 seconds? Either look on the position graph or use your t-chart. After 2 seconds, we are at 2 meters there in the green. And then our last one, when does it first reach its maximum velocity? Well, if we look at our velocity graph, we want to find the highest velocity we ever hit. That highest velocity is right there, so it's reaching it right at the end, so at 4 seconds. All right, so we're going to pause for 7 minutes to let you do the next question on your own. So go ahead, you can be working on number 3. All right, so let's make our t-chart. We're going to velocity to position, so we're doing area 0. We're at a position of 0. Area of 1 at the next second. Then there's no new area the next 2 seconds, so it stays at 1 at seconds 2 and 3. Then from 3 to 4, you have an area of 3 that's new, so we're up to 4. Then another area of 3 that's new, so we're up to 7. And graph should look like we have there in the green. Our description, we're 1 meter per second for 1 second. You could either say 0 meters per second or stop for 2 seconds, and then another 3 meters per second for 2 seconds. The velocity of the object at 4 seconds, here's 4 seconds. See what your y value is. We are at 3 meters per second. Our position at 5 seconds, see in the t-table there, was 7 meters. And then lastly, we first reach our maximum velocity at 3 seconds. Our maximum velocity was at 3 meters per second, and we first hit it right there, which is why it's 3 seconds. All right, one last type of problem we have to go over, and we'll do a few practice examples of it. We want to know who traveled further. Notice these are both velocity graphs. To find how far someone traveled from a velocity graph, we just want to do areas. And when we do that, we don't have to do it for each individual second. We can split it into convenient shapes. So here we can split into a triangle and a rectangle. We have a 2 by 3 triangle, and we have a 5 by 2 rectangle. So we're going to have 2 times 3 divided by 2 for the triangle. That'll give us 6 divided by 2, which is 3. We'll have 5 times 2 for the rectangle, which will give us 10. And then add those together. So all together, they went 13 meters. We'll split this next one into some convenient shapes. We can again do a triangle and a rectangle. So we have a triangle that's 2 by 4, and we have a rectangle that's 3 by 4. So 2 times 4 divided by 2 will give us 4, because it's 8 divided by 2. 3 times 4 gives us 12. And we'll add those together, and we'll get 16 meters. Now, it does say we have to tell who traveled further, so we need to actually state it, not circle one of the graphs, not circle an answer. We need to physically say that person B went further. All right, we're going to pause and have you try the next two, numbers 5 and 6, and we'll give you maybe, let's see, we'll give you 7 minutes to do that as well. Okay, so 7 minutes, do the next two questions, number 5 and 6. All right, so number 5, I split mine up as you see in the purple. You could have split yours up differently, but the way I split it up, I had a 1.5 triangle on the left, a 6 rectangle on the bottom, an area 2 triangle in the middle, and an area 6 on the right. So that ended up giving me 15.5. Again, if you didn't get 15.5 and you split it up differently, you just have to check your work to see where you might have made an error. And the next one, various ways you could have split it up. You can see how I split it up in the green. So I had a triangle on the left that was 2. The rectangle on top was 6. The square on the right was 1. The triangle on the far right was 0.5. And that rectangle on the bottom was 6. Adding those up gave us 15.5. So to say we went further, you could either say they went the same. You could say it was tied. Anything like that to indicate that they went the same distance. For 6. I did the big rectangle, which was 24. The triangle was 1, and then the little square was 1, so you got 26 meters. Over on the right, I did 2 little triangles. Each were 1. The rectangle was 24, so you had 26 meters. So again, you could say either they're the same, tied, anything like that to signify they went the same distance. All right, for the remainder of the period, you have the rest of the questions in this packet to finish, which if you've been in here and haven't gone to the bathroom or anything, that should just be questions 7 and 8. But you're responsible for pages 24 to 29 to be done when you come into next class. Have a great rest of your day.